Okay, I'm going to graph the system below and write its solution. So the first thing we have to do is graph these. So the first one is in standard form. There is a 1 in front of the y. Now when I'm graphing in standard form, I take the constant, this number here, and I don't change the sign. I just pop it up top of each one of these, like this. And then I figure out what those are. So for my x, negative 4 divided by 2 is negative 2. And in front of y, negative 4 divided by 1 is negative 4. Now, in standard form, when you do that, you just have the intercepts. So, negative 2 on the x and negative 4 on the y. I'm going to connect those with a line. Like that. Need to get it to go through the points. Okay. The next one's not in standard form, it's in slope-intercept form. So when I have an equation in slope-intercept form, I use 0 and then the number that doesn't have a letter stuck to it, 2. And then I use the denominator of the slope, which is 2, and that scratches out the x and I do what's left. So I have a negative 1 plus 2. That equals 1. That goes here. So those are my next 2 points for this equation. 0, 2, and 2, 1. And again, I connect those. Now, your solution to your system of equations is where those two points meet. So, if I go down to the x-axis, I am at 1, 2, 3, 4, negative 5. And if I go to the y-axis, I am at 1, 2, 3, 4, positive 5. And that is the solution to the system of equations. For the next one, my first equation is in slope-intercept form, so I use 0 and the number that doesn't have a letter stuck to it, and then I use the denominator of my slope. That scratches out the x and I do what's left. 1 minus 1 is 0. That goes here. Okay, so 0, negative 1, and 3, 0. 1, 2, 3, 0. Draw my line. Making sure it goes through both points. The next one is in standard form. This is a negative 1 here. So standard form, you take the constant and you pop it up top. Don't change it, just move it. Okay, so in front of my x, negative 3 divided by negative 1 is a positive 3. And in front of the y, negative 3 divided by 3 is negative 1. So on my x, I draw a dot at 3. 1, 2, 3, right here. And on my y, a dot at negative 1, right here. Now, if you notice, those 2 points I just drew were on the same line. So technically, I have 2 lines on top of each other. When that happens, it's an infinite solution because they are touching everywhere. And that just means all the points on the line, on each line, are touching each other. They're intersecting. This is in standard form. So standard form, you take the constant and pop it up top. Let me give myself some room here. So, in front of x, I have 2 divided by negative 1 is negative 2. And in front of y, I have negative 2 divided by negative 2 is negative 1. So my x-intercept is negative 2. My y-intercept is negative 1. I'm going to connect those. Let me try to get this to be a little bit straighter. It's not going to let me. Let me redo that because I need it to be straight. It has to go perfectly through both lines. Through both points, or you won't get a good solution. So that's what you got to be careful about solving these graphically, is that you draw your line very, very straight. Okay, that's better. Okay, so for the next one, it is in slope-intercept form. So I use 0, and the number that doesn't have a letter stuck to it is negative 1. And then I use the denominator, 2, and that leaves me with negative 1 minus 1. That equals negative 2. So 0, negative 1, right here, and 2, negative 2. I'm going to say that's the same line. So remember, if it's the same line, it's infinite. I didn't show you an example, but if you happen to graph two lines and they never touch, that would be no solution. If they never touch, it's no solution.